Good morning, ladies. How are y'all doing? You must be very sleepy. Did y'all stay up last night doing your test? Mm-hmm. Mm-hmm. Okay. So do you all have any questions for me today? We're just... Mm-hmm. Oh, that's weird. I was having so many issues with my internet yesterday. Okay. All right. No questions yet? You chat it to me, right? Chat it to me. Okay. I'm trying to fix my little Elmo. Oh, hold on. No. Okay, hold on 1 second. There we go. There we go. Way to go. There we go. Okay. Focus. All right. So we were doing 6-2. So we're gonna complete 6-2 and then we're gonna go to 6-4. So 6-2 involves conversion. So we're gonna do several of them in there. So you'll be using your conversion formula that that I had chatted to y'all, the sheet. Let me see if I can find it. That one. All right. And so what you're going to be using today is you're going to be using your of course stat disk, right? But mainly you're going to be using the this formula. Okay, you'll be using that formula, and you'll be using this new formula. We're going to be using those two formulas today. And we're also going to be using our infamous probability less than, the greater than, and the in between. So we'll be using those all day today, right? And if you get lost, right, and you don't remember how to do stuff, remember this is your crutch right here. The notes. We always refer back to these notes. All right, it's the first 2 pages. So section 6162 will use pages 1 through 3. Okay, 1, 2, and 3. So have that sheet handy. If you can't find it, go to our Canvas page, go to modules. There should be a place where it says stat disk. Let me see if I can find it. If you ladies go over here, let's see if I can find it. Oh, hold on. Right. Nope, wrong one. Hold on. Right. So in our Canvas page, go to modules, and you scroll down, way down, right there, where it says course resources. There is a notes for stat disk for each chapter. So you click on it, and it's right there, number 6. Right. So you have them. You have it there. Don't forget, they're all there for you. All there. Okay, so we're gonna go to page 250 and we're gonna do a couple of examples and then we'll do the word problems. Okay. All right, so this is page 250. We're gonna do 5, 6, and then I'll let you guys pick whether you want 7 or 8. You're probably gonna pick 7, right? Because it's odd. All right, so let's tackle this one on. Okay, this is number 5 on page 250. This is number 5. This is called applications of the standard normal. Applications involving the standard normal. Okay, so here's our picture for 5. So notice on 5, you have a graph, you have your normal curve, right? And notice that at 118 from that line up, right, it's shaded to the left, right? So we're gonna have to convert this into a probability. But first, before we start doing that, we need to read up right above the title of the problems. We need to write down 2 important things, right? So you always need to write down the mean and the standard deviation. They're always going to be given to you, all right? So that's the first thing you do is you want to locate and identify the mean and standard deviation. So it says here, the graphs depict IQ scores of adults, and those scores are normally distributed with a mean of 100 and a standard deviation of 15. So right off the bat, right there, they're telling you that your mean or your mu is 100. Oops, put 1,000. And your standard deviation is 15. Right, so you have to locate those. Always locate them and then write them down in your paper. So you get your standard deviation. The O is 15. Right, so you always write that down. So this is what I wrote. This is what I have so far, just from that. And usually the author will put those descriptors, those 2 numbers, above the problems that you're going to be working with. So you got to be careful. They're kind of hidden, so you may have to look around to identify these 2 numbers. But these are the main ones you need to know. You need to know these 2 numbers. Otherwise, you're not going to be able to do any of the problems. Right, so those are the main 2 things. All right, so now we can do the problem. So now what we're going to do is we're going to convert that picture into a probability. So notice again that the graph is green, shaded to the green on the left side. So we're going to write this probability as a probability. We're going to put P parentheses, and because this is a real life situation, we're talking about IQs, we're going to use the variable X. Okay, so we have X, and then we said that it's shaded to the left, which means it's going to be less than, and then we're going to put the 118. Okay, remember, anything shaded to the left is less than, anything shaded to the right is greater than, like this one's going to be greater than number 6. This one is less than. And if you see number 7, that's going to be the in-between one, right? And so is number 8. So we have P parentheses X is less than 118. So that from that picture, that's what I have. So here you go. I'm going to share my screen with you. This is the probability statement corresponding to that graph. There it is. That's it right there. All right. So this is the real life part, right? And remember, we're going to have to convert because I I cannot look up that number in StatDisk. It will not allow me to go higher than 3.5. So this is a huge number. It won't work. It just won't work. So you know that you're gonna have to convert. Right, so we're gonna convert, and remember that formula that I circled. We're going to be using that formula z equals x minus mu over sigma. That's my conversion formula. Right? And I'm going to write down, I'm going to plug in the numbers. Okay, so the x value, remember the x value is going to be this 118. Right, so this is 118 minus, right, and then here's your mu, 100. And then we're going to divide that number by 15. That's my standard deviation of 15. And you're going to calculate it. So this would be what, 18 divided by 15. And wrong color. I wanted it in red. 18 divided by 15. And you're going to go to your calculator, and we're going to get the decimal representation of that number. Right, so 18 divided by 15. $1.2. Right, I need to make sure that I have 2 decimal places behind the decimal, so I'm going to go ahead and put a 0. You don't have to, but yeah, I'm going to make sure that this one should have, there should be 2 decimals behind it. There should be 2 numbers behind the decimal. Two places behind the decimal. If you all get lost again and you don't know where to round these numbers, go back to those notes that I provided you all with. So it's all there. I have it labeled and I highlighted them, so you can't lose. You can't lose your memory on that. All right, so I got my number. And so because we're converting from real life to a normal, I'm going to write now my probability. I'm going to use the z now, not the x, but the z. I'm going to keep my symbol, and I'm going to write this number 1.2, which I got from my conversion. Right? And because remember this is shaded to the left, I'm going to put it here, left area. I'm going to enter 1.2 in StatDisk, and I'm going to find the left area of that number. So let's go to my StatDisk, and I'm going to go to, I gotta load it up. Analysis, probability distribution, and normal. And you're gonna put the number on the top box. Evaluate, and we're looking for the left area. There it is. 88,493. I need to make sure that that one, our answer has 4 digits behind the decimal. So my answer ends up being 88.8849, or if you want to write it as a percentage, 88.49%. Let me switch over my camera so you can see it. Right, I lifted up the left area for the 1.2 left area. It was 88.49, 88.49%. Answer. And yes, it is 88.49. Bam. Right, so that's how all the problems are going to be. You're gonna change, well, on these ones, you're gonna change your pictures into a probability statement, convert, simplify, convert it into a Z now, and then look it up in StatDisk, and presto, there is your probability. So we can, you don't have to put this down, but this is how you interpret it. 88.49% of the people, or I guess patients, have IQ scores less than a score of 118. Okay, so that's how you interpret it. So from that, those group that they surveyed, 88.49 of them had an IQ score, or had an IQ of 118 or less. Less than 118, yeah. Less than 118. That's how it works. Okay, so you want to copy that first, and then we'll do number 6 together. Okay. Okay, we'll do number 6. Okay, so number 6. I think for number 6, you're going to be using the same. You're going to be using the same mean and standard deviation for number 6. Right, so your mean is still 100. Your standard deviation is 15. It's the same. You're using the same mean and standard deviation. Okay. Make it straighter. Okay, there you go. It's the same mean and standard deviation. All right. The only difference is I need to write down my probability. So we're going to put probability of X is what? Let's go back to the problem and we'll identify it. Let's see. So this one is, okay, so notice the 91, there's a 91 and it's shaded to the right. So that means that my inequality is going to be greater than 91. Right? It's shading to the right. It's greater than. Any numbers above 91 is greater, right? Okay, so let me share my screen. All right, so this is what I have. X is greater than 91. Now I can go ahead and convert. I'm going to use my formula. Z equals X minus mu over sigma. I'll put that in a box so I won't get confused. I'm going to substitute the numbers in. So my X is 91. I'm going to subtract my mean. My mean is 100. And then I'm going to divide it by 15. And it's okay. It's okay if you get a negative. That's fine. That's fine. You can get a negative. There's nothing wrong with getting a negative. So let's plug it in. I would do the top first. So do parentheses 91 minus 100 and then divide it by 15. Okay, so I got negative 0.60. Yeah, negative 0.60. Okay. So now that I got my Z number, I can go ahead and do my conversion. I'm going to change that X to a Z. I'm going to keep the symbol. And I'm going to write down this number, negative 0.60. I know on my graph, the shading was on the right, so I know that I have to look at the right area. Right? And so you plug that number in to StatDisk and look up the right. I need the right area for negative 0.60, which we'll look up in a minute. In a minute. Negative 0.60. Evaluate. I'm looking at the right. All right, I need to make sure that there's 4 numbers. So that would be 7258. 0.7258 or 72.58%. So if you want to do a little summary, if you want, 72.58% of the patients had an IQ score. I don't know how to spell score. Score greater than 91. Those are like the politicians in Texas. Just saying that out loud. Saying that out loud. If you want to write it. But that's all they're looking for. They're only looking for that. I'm noticing that in the back of the book, they have a 7 instead of a 8. And that's fine. What they did was the book, the author used the table in the back of the book. They didn't use StatDisk. So it'll be off by a 10,000. Yeah, it'll be off by 1. That's fine. You'll be all right. So don't panic if the very last digit is off by 1. It's totally fine. Totally fine. Right. And again, you ladies don't have to do this part. This is just for your information. I'm just interpreting what is this number telling us? Right? It's telling us that when they interviewed all those patients, when they took the IQ test from that batch, 72.58% of them had an IQ score greater than 91. That's all it's saying. And sometimes it makes sense to interpret it because you get numbers and you're like, what the heck does that number mean? Well, that's the interpretation. Okay, questions? Ladies doing all right? The young ladies, young lads. All right. We shall do 7 because that's in your homework. Are you saying 7? Okay, let's do 7. All right. So again, you're going to be using for that problem, you're going to be using the fact that the mean is still 100. Standard deviation is 50. Remember, you're only using these 4 problems 5 through 8. That's the only time you're using these is 5 through 8. Okay. Now let's look at the picture for number 7. What does it have? So number 7, we have picture-wise, we have, oh, look, we have 2 numbers and it's in between. So how do I interpret it in terms of probability? That one's going to be an in-between. So we're going to put the probability, we're going to put P parentheses, and then we put the smaller number. We put 79 less than X less than 133. Okay. So this one is an in-between. Okay, let's see. Let me share it with you what I wrote down. And this is how you write a probability as an in-between. Okay. So we're gonna do our conversion now. Because this probability has two numbers, I have to use a formula twice. One for the 79 and one for the 133. I got to convert both of them. So I got to do z equals x minus mu. I got to write the formula twice. And we're going to plug it in. All right, so let's plug in the first number. We'll plug in the 79 first. So 79 minus 100 divided by 15. The other one is going to be 133 minus 100 divided by 15. And remember, I want two decimal places behind decimal point. Okay, so here we go. I'm going to plug in the first one. Parentheses, 79 minus 100, close parentheses, divided by 15. I get negative 1.40. And then this one, I'm putting parentheses, 133 minus 100, close parentheses, divided by 15. I'm typing it in like that. .2 is what I got. 2.20. Okay. So now that we converted them, I'm going to put these two numbers in my probability statement. So now I'm going to put negative 1.40 less than, we don't use the X anymore, we're using the Z because we're converting from real life to a Z. And then I'm going to put my 2.20. If I have space, barely have space, barely have space. Right? And as if you recall, how do we handle an in-between? We got to do Beyonce song. Remember her song? To the left, to the left. I'm not gonna sing it. That was awkward. We're doing Beyonce song. To the left. So we gotta find the left area of 2.20, and then we're gonna subtract the left area of negative 1.40. Right. We gotta find the two left areas of these two numbers. Why does it look like I'm negative? We gotta find the two left areas of both of those numbers. Right, so we gotta do it separately, right? So we're gonna do each one separately. So we're gonna do 2.20 first. Where is that disk? Where is that disk? All right, so here we go. 2.20. All right, my left area is 9861. Perfect, 9861. 0.9861. And now I have to put in my negative 1.40 to negative. And I'm looking for the left. That one is 0.08 8. 0808. Yeah, 0808. Yeah, that 7 is going to become an 8 because that 6 is higher than 5. So that changes that 7. It's going to convert it to an 8. And swish. So this is what I have. I got the area for 2.20. It is 9.9861. I got the area of negative 1.40. I'm going to subtract. If you ladies have them reversed, your answer is going to end up being a negative. You just take off the negative sign. The way I have it written, it should be all right. So let's see if it comes out. 0.9861 minus 0.0808. Yeah, sometimes you may accidentally have put 0.808. No, go back and check. Make sure that you have wrote down the right numbers. Subtract. There it is. 0.9050. 0.9050 or 90.50%. That's what we're looking for. If you want to interpret it, you can say 90.50%. That's weird. Oh, it's a 3. Hello. I knew I messed up. It's a 3. Whoops. It's 9053, not 9050. 9053. See? I don't know how to freaking read. This is decimal. This one is percentage. 90.53% of the patients had an IQ score between, was it 79 and 133. Wow, that's almost all of the patients, right? 90.53. You captured most of all of the patients that were in that group. 90.53. Again, you all do not need to write that down, but it's good practice. It's good practice because if you're gonna go medical or you're gonna go cybersecurity, you wanna make sure that other people know that you know what that means. You just don't give them the number. Here you go, done. Yeah, you gotta be able to explain yourself. Why? What is this number? What exactly does that number mean? Okay, questions? Any questions, ladies? Any questions? Laddies? No questions, laddies? Something like a pirate. I don't know what. Okay, so there's the conversion formula I was telling you all about, right? I circled it in the notes that I showed y'all. Now I have to show you all how to do the ones like 9 and 11. All right, so that one, those, when we do number 9 and 11, you're going to use that other formula that I circled that we had not covered. It's this formula here. Let me show you. It was this formula. Okay, we're going to be using that one. So you've seen that formula before, right? That formula stems from this one. All they did was they rearranged the letters. They used algebra, right, to end up getting there. So all they did was they solved for x. They isolated the x. So what they did was they, it's x minus mu divided by sigma, right? So they did some algebra. So what they did was they multiplied both sides by sigma, right? So you get z times sigma equals x minus mu. They multiply both sides by sigma. Why do they do that for? Because if you multiply both sides by sigma, this sigma and that sigma cancels. That leaves you with this line, right? And then they want to get this x by itself. So what did they do? They add mu. They add mu to both sides. So that way this mu and that mu cancels. And so you're left with this mu. That's a terrible plus. Crooked. Crooked like a politician. Sorry. Plus. That's supposed to be a plus. Oh, shoot. Plus. There you go. So it's mu plus z times theta equals x, which is this. There it is. Of course, you don't need that. You just need the formula, right? Who needs all that algebra? But anyways, that's how they got the formula, how they derived this from this formula to the other one. They did some algebra, but you guys are not math majors, unfortunately. Boo, boo to you, boo. Oh, sure, I can't even erase. I don't know how to erase. Come on, erase. Hello. No quiere jalar. There you go. Erase. Jeez. You get the picture. I'm trying to erase all this stuff. It's just not. See if I can do a good job. Why I didn't do a good job painting the house? All right, so that's from that formula, jeez, to that one. So, all right, then you don't need all the gory details, right? You're just like, just show me the freaking formula, sir. I just want the formula. You don't have to derive it. All right, you don't have to derive it. Okay, so all right, so let's look at number nine, right? So you're gonna do this one differently. Okay, so number 9, you're gonna do it. It's different. Okay, so notice on this one, you're not given the values below on the scale, right? On the bottom scale, you're given an area which indicates to you that you're going to be utilizing that second box on StatDisk. Remember that second box? Well, we're going to be using that box. All right, so let's show that one. All right, so number 9, you do have to draw the picture on these. You have to draw the picture, right? So I'm going to draw the picture of it. So you can get an understanding of what's going on. And here's the X. And inside they have the shading. And inside the shading, it's 99.18. Let's think. Let me see if I can draw it. I drew it as best as I could. And oh, I forgot to write down my mean. My mean is, I think it's the same thing. Mean is 100. Standard deviation is 15. Yeah, you see it at the very top right here? It tells you your mean and standard deviation. So I should have written that down first. I should have wrote it. Oh, my English is bad. I should have written it down first. That's the word. That's the phrase I'm trying to come up with. Okay, so this is what we're going to do. We need to find out what that actual X value is. I need to know what exactly is that Z value. So I shouldn't have put an X there. I'm going to change that X to a Z. I'm changing it to a Z. Okay. And I want to find that number. So you all remember what you're supposed to do first? So on your graph, you need to make sure that the shading part of the graph is on the left side. It is. It's shaded from that Z to the left. There's a little white piece on the very end, which we don't need to know. But as long as it's shaded on the left, we're good. So you're going to enter this number in StatDisk on the second box. And our goal is to figure out that Z number. Right, so let's go to StatDisk, and I'm going to plug in that number on the second box. Right, it even says it on there. Enter, what does it say? Cumulative area from the left. So that's what you have to put. So 0.9918. I'm going to hit evaluate. And I want the Z number. And there it is. You're going to write the number as it is. Do not round it. Just leave it as it is. So you're going to write 2.39989. Just like that. Right. There's the 9918 from the graph. You hit enter and bam, that's what you want. You want the Z value. Okay. So I wrote that down. And I'm going to use that formula because I need to change that Z into an X. So that's where that formula that I shared with you, the one that we had to do some algebra in it, or what mermaids were in the water, get it? Algebra. Right. You're going to use that formula. You're going to be using X equals mu plus Z times theta. You're going to be using that formula. And you substitute. What was my mu? My mu is 100. Plus, there's my Z. This is a Z right there. That number is that number right there. So you're going to write that number down. I'm going to put parentheses. 2.39989. I should put that in parentheses. 9, and then we multiply it times 15. And then you calculate it. And then you calculate it. Just type it in exactly how it appears in your calculator, unless you have an iPhone or an Android, then you're gonna have issues. But I'm typing it in exactly how I wrote it down, like 0.39989 times 50. Here. This is how I typed it in. There you go. 100 minus, oh, it should have been plus. Hello, plus 100 plus parentheses 2.39989 times 50. There you go. 135. So your actual IQ score is 135.99835. You all can write it and leave it in that format, or what the book did is they bumped it up. They rounded it off. I'm going to let you round off this number wherever you like. You may round off at any value or leave as is. You decide how you want to do it. The book rounded it off to 136. So they're saying people who scored smaller than, or people who scored on the IQ test less than 135, 99.18% of them did that. I don't even have that IQ score. Oh, IQ score. Why do I keep putting square? Weird. IQ score. That's your IQ score. 135 or 136. If you want, it don't matter. That's what the book has. So that's how it works. So you're going to have to, you're gonna have to draw the picture, change that X to Z, make sure that the left area is shaded, plug it into StatDisk, find that Z number, and then plug in these three, well, this was given, those three numbers into that formula. Simplify. Bam! H to the ISO, E to the IZZY. Yeah, all right. So that's number 9. Number 9 was the easy one. Number 11 is going to be the fun one. All right, so hold on. Let me make sure that you guys copy that down, and then we'll do number 11. Mold. There's a lot of mold outside. All right, y'all ready for number 11? Okay, 11 is going to be similar, but there's only one issue with it. Let's look at 11. I'm going to draw the picture. I'm going to write, oh, I forgot to write down for number 11. I forgot. Mean is 100. Standard deviation is 50. And it says it above the problem. Again, like the other ones, right? No, I can show you. I can show you. Right there, boom. It says it right there. So always look for it. And I'm gonna copy the graph. Let me see, number 11. See, the thing with number 11 is you gotta go back to page 250. And then when you go to page 251, there's a problem, right? So yeah, sometimes you have to go back to the previous page to find out that mean and standard deviation. Okay, so there's a picture for number 11. So I'm gonna write it down. I'm gonna copy it as best as I can. Best as I can. 0.9798. Oh. All right. Let me share my picture. I didn't draw it as nice as the author did, but hey, I tried. I'm from the south side. All right, there it is. Now, notice on this one, the shading is not taking place on the left. You see that gap right there? That has to, we need to know that. We cannot find the Z value. We cannot find the Z value without knowing the left side out. This one's only the right side's given. So how do I find that missing piece? Well, you subtract it from 1. And that will give us that piece that we need to know. So I'm going to subtract 1 minus 9798. And that gave me 0.0202. This is what we need. We need that gap right there. That's what we need to know in order for us to know what the Z number is. Right, so remember, when it's giving you the left, you just automatically enter that number in there. But if they give you the right side, you need to find out the left side. Otherwise, it's not gonna work. So I'm gonna enter this number in the second window of StatDisk so I can find out what my Z number is. So I'm gonna put 0.0202. into stat disk. Point 0202. And there's my Z, negative 2.04963. Negative 0.04963. Not tree, but tree. All right, there's my Z. I'm going to use my formula, my handy dandy formula. X equals mu plus Z times sigma. And I'm going to substitute my mean is 100 plus my Z is a negative 2.04963. Remember, don't round it off. And I'm going to multiply it times my standard deviation of 15. So you need three numbers. You need the mu, the sigma, and that's how you find the Z. And you substitute it in. And 69.25555. No, I don't have the answers. IQ. Right. You can leave it in that. You can leave it in this format, or you can put 69 IQ. I think that's it, right? Yep. I did. I typed it in. Did it in there. Yep. Bam. Questions? It's very overwhelming. I know it is. I know it is. But you'll get through it because you'll be alternating, right? You'll be doing the regular probability, and then you're going to be doing one of these. All the problems in the book are going to be like that. They alternate. One probability, one find the Z, find the X. They're all going to be like that. Questions? Okay, now you are now no longer peasants. You are now citizens. You are now, what's the word? Not rookies, but you're veterans now. Now you're able to take on the word problems. All right, so let's look at the word problems. There's a whole bunch of them. More. All right. We have, let me see what we have. We got, all right, so we got, you guys are in the way. All right, so we have Navy pilots. We're trying to do the odds, right? We have Mickey Mouse, eye contact, jet ejection seats. What else we have? Body temperature, durations of pregnancies, pulse rates. Okay, so let's do one that's fun. All right, we'll do a fun one. Let's do durations of pregnancies among men. What? I'm kidding. Pregnancies, yeah, durations of pregnancies. All right, let's do this. This is a cool one. This one, you're gonna see how we're going to do one regular probability, and then we're gonna do one with the finding the x. They alternate, right? So let's do number 31. All right, 31. Why does this thing? Yeah. Anyways, sorry. I don't know why I have that highlighted, but I need to get rid of it. Hold on, so I can get rid of it. Get rid of it. There you go. Bam. All right. So the lengths of pregnancies are normally distributed with a mean of 268 days and a standard deviation of 15 days. All right, ladies. How many of you young lads have had a baby? Is that true? Is pregnancies lasting up to 268 days? Is that true? Or no? I don't know. I don't remember. Is that true? None of you ladies have had a baby? It's true. You do have an alien growing inside of you. Get it out. Don't worry, ladies. The men are gonna be able to have babies soon. That's why you cybersecurity majors are going to figure it out. Oh no, never mind. That's not medical. That's something else. But hey, you never know. Maybe cybersecurity will be able to do that. Anyways, move on. A little awkward here. All right. So right off the top of the bat, right, 31, right? What do they give you on the very description of the problem, right? They're giving you the mean and the standard deviation, right? So let's write that down. So my mean is 268. My standard deviation is 15 days. Dang, it's a lot of days to have that alien inside of you, right? Get it out of me. All right. Let's do letter A. So you're gonna ask me in a little bit, how do you know when to use what, sir? There's the words that describe it, all right? I'm gonna share that with you. All right, so here we go. It says A. In a letter to Dear Abby, a wife claimed to have given birth 308 days after a brief visit from her husband who was working in another country. Find the probability of a pregnancy lasting 300 days or longer. All right, so the key word here for this problem is the word probability. Can I highlight it? Yes, I'm going to highlight it. That's the key word. Oh, I need to take it out. Okay, there you go. That's better. So probability right there. So you're going to find the probabilities. You're going to put P. This is the one where you're going to do P parentheses X, because this is real life. X is what? To 308. Is it going to be less than, greater than, or in between? What inequality symbol am I going to use in between the X and the 308? Is it the less than, the greater than, or the in between? It said lasting longer than. What does that mean? Lasting longer than. Yeah. It is greater than. Right. Greater than. Bam! Very good. And you get that. Very good. Very good. Greater than. It's lasting longer than. All right. So we're going to be converting. We're going to be finding the probability. Right. Because that's the word. I'm going to put it in parentheses. Probability. Right. And this is greater than. And we're going to convert. Going to convert. Let's convert. All right. So we're going to do z equals x minus mu over sigma. That's the one we're going to do this business. All right. And we're going to get, okay, so my x is 308 minus my mu, which is 268 days, right? There's my mu. And I'm going to divide it by 50. Remember, they're going to give you those two numbers. They have to give you those two numbers, the mu and the sigma. Otherwise, you won't be able to do it. And we're going to calculate it. Plug it in. Parenthesis. 308 minus 268. And divided by 15. All right, I get 2.66666666. Oh my gosh, it's evil. But I want two numbers behind the decimal, so I'm going to put 2.67. 2.67. It's got to have two. It's got to have two behind the decimal. So 2.67. And then we now can convert it to a z. So I'm going to put z is, keep the symbol, greater than 2.67. And because it's greater than, I'm going to look up the area of the right. This is the right area. Right area. So we're going to plug in that number into StatDisk and look at the right area. All right, so right. You have to put back up here in this box. 2.67. Right, there it is. So my answer is 0.0038, or in percentage, there is a 0.38%. Uh-oh. All right, let's interpret it. Let's interpret it. There is a 0.38% chance that what? Uh-oh. He is the father. Oh no. No. Dun dun dun. You are not the father. Hijo. Man, I feel like a Jerry Springer episode here. Hijo. I thought I saw the Geek Squad over at that house often. Weird. It was the board. It was a Bluebell. The Bluebell ice cream truck was often at that house. I don't know. We're not going to judge. But yeah, hijo, he was not the father. Qué lástima. Borden's. Why did I come up with Borden's? I don't even think they have Borden's milk. What do they do? Right? Do they have Borden's milk? Borden's milk. The one with the little vaquita? No. Yeah, they do have Borden's milk because I saw it at the little convenience stores. No. Yeah. Well, one of those workers I saw at the house. All right, so he was not the father. Hijo. Good lesson. All right, so that's how part A works. Right, we're trying to find the probability that this, the pregnancy lasting 380 days. I don't think so. It can't last that long. So that's the interpretation. Oh, sorry. Sorry. Yeah. Chance that a pregnancy lasts longer than. Sorry, that should have been. I jumped the gun. Oops. Whoops. I thought judging. Come on, you don't do that. A pregnancy lasts longer than 308 days. That was the right interpretation. Sorry. So conclusion, you were not the father. There you go. That's a very small percentage, ma'am. Very small percentage. All right. Now, that's the part A. All right. So the key word for here, folks, the key word is the term probability. Look for probability. If you see the word probability, you're going to do one of these. Okay. But you still have to do that. You have to find those two numbers and look for the word probability, and you'll have to do one of these. And you're gonna look for the inequality symbol, the word, the phrase. It'll either say less than, greater than, more than, smaller than, in between, right? You'll see those words. So that's how you do. So you're gonna do one of these all the time. You're gonna do part A is that. And then part B, you're going to do the other way. So let's look at B, right? And you'll see the term or the thing to look for to determine how do you know you're going to use that other method. Okay, so here is part B. Okay, here it is. If we stipulate that a baby is premature, if the duration of pregnancy is in the lowest, sorry, I have to take off this. I didn't like this. All right, there you go. Oh, I didn't take it off. Did it take it off? It did. All right, good. If we stipulate that a baby is premature, if the duration of pregnancy is in the lowest 3%, find the duration that separates preemies from those that are not preemies. Premature babies often require special care, and this result could be helpful to hospital administrators in planning for that care. Yes, every hospital in San Antonio, they all have a different, I guess, a different level of what to refer to a baby as premature to a full-term baby. It's off. All of the hospitals have a different measure or scale that they use. Any of y'all ladies premature babies? We all full term? Or did y'all stay beyond the term? Did you get comfortable in your mom's tummy? You like the free food and the entertainment in there? Probably so. No one was a preemie? That's rare. Everyone was full term? Or did your mom just say, get out? Get out of here. All right. Yeah, we're full time, full terms. Okay, so yeah, this is very important. Okay, so the key to this one, how you know that you guys are going to be using that other method, is they're going to give you a percentage. Notice it's as low as 3%. It doesn't say in here anything about probability. So they're going to give you a percentage. So if they give you a percentage, you're going to have to use that other method. So I'm going to write down my mean and my standard deviation. My mean was 268 days and my standard deviation is 15 days, right? And because they're giving you a percentage, I need to draw a picture. Right now, where do you put the 3%? Well, it says it there. It says lowest. So you're gonna graph the 3% on the far left end of the graph because that's where the lowest goes. Lowest. over here is the lowest. So you're gonna put your little line and you're gonna label the here 3%. That's the 3%. You guys can't see it. 3%. There's your 3%. Right, and so your goal is to figure out the z. Now we got to convert 3% to a decimal. So why don't you just get the 3 and divide it by 100? Because that's what really a percent is, right? You see that? You see the 100 and the percent? You get the 1, the 0, 0 there. No, 3 over 100. So you do 3 over 100. 0.03. And so you're going to put that number, in stat disk, right? So that way we can find my z. So you're going to put in the second box. Put in second box. Put in second box. Putin. Putin. That's Putin. Oh, that's what Putin means. Putin. Interesting. All right. That was weird. Putin. 0.03. Okay, I'm gonna get my z. Did I hit evaluate? Oops. Oh, what did I do? Did I do something wrong? That was weird. Why did it come? Anyways, negative 1.88079. Negative 1.88079. All right, so I'm going to write my formula. I'm gonna write it down first. Hold on. Let me write it down first. Share my screen. Oh man, why did my wife cover up the time? Okay, so here's my formula. I'm gonna use that formula now. Mu plus z times sigma. And I'm going to substitute 268 plus negative 1.88079, and we multiply it times 15. So at this hospital, the cutoff between preemies and full term is 15. 239.78815 days. That's the cutoff between preemies and full term. So any baby born less than 239 days is considered a preemie. Anything above 239, that's a full term. That's how that hospital operates. But you can check. You can call each hospital, and they all have a different. They have a different limit. Some of them say it's 240. Some of them say it's 241. 241 is a cutoff between preemies and non-preemies. They're all different. All of them are different. Weird, right? They're all different. Okay. So that's how you guys are going to be doing all of these problems. You're going to do part A, one of these, probability. Part B, one of these. Part A, part B. They're all like that. All of them. All of them. All of them. All right, let me let you copy that down, and then I'm gonna let you all pick. I want you to pick that. You're gonna pick another problem for the book we can do together, all right? We'll do it together as a dysfunctional family. We'll do it together. I am surprised that I don't have anyone in my class, this class, that was not a preemie baby. Interesting. 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 Oh, you ladies like my car? Only in the south side. Check out the car in my background. Did you see that? It's a automobile that's been put together in pieces. So it's like a Ford and a Chrysler. So I call it a Chrysler. It's a mini truck, minivan truck. I'm serious. I tell you, man, we have engineers in the south side too. They were very inventive. Look at that. I want one of those. Forget the Tesla. I want a Chrysler. Give me that Chrysler. Actually, I should have taken a picture like right. I should have just did a selfie with me like on the side. I don't know. I was afraid it had an alarm, which I don't think it has an alarm. Something like that. Okay. Alrighty. Okie smokies. Okie smokies. You ladies are gonna pick. You're gonna pick one for me. Yeah, I know it's interesting, right? Interesting. I tell you, technology. I think that one gives like 5 miles per gallon. And I think it runs on alcohol, like tequila. I'm not too sure. It doesn't run on gas. It runs on or mantequilla, something. One of those. I don't know, man. I think you have to like when you have to start it, I think you have to get on and then hit the clutch, and then it'll start. Something like that. I don't know. All right. So let's see. Which one do you ladies want me to do? All right. So here are your choices. Let's go back to the previous pages. All right. So which one interests you? Do you want to do Navy pilots? Mickey Mouse. That one sounds cool. Eye contact. That's creepy. Jet ejection seats, or already did that one. Those are the only choices. Which one do you want? Which one interests you all? You want to do Mickey Mouse? Okay. All right. How many of y'all have been to Disney World or Disneyland? Any of y'all been there? Which one did you like best? The one with pilot. Oh, you want to do the one with pilots? All right, all right. Ah, Tom Cruise. Oh no, his real name is Tomas Cruz. All right. Tomas Cruz. You been to both? Which one did you like better? The one in Florida or the one in California? Yeah, I've been to both too. I prefer the one in California. You like the one in Florida? I don't know. Too crowded. And people smell like comino. Yuck. People didn't take a bath. Ooh. Whereas, yeah, then it's the humidity too. It's so hot. Oh. But California was all right. It was nice and cool. You know, we didn't have to worry about stinky poo people, you know. Smell like tobacco. Ugh. All right, let's do the okay, so you're gonna do the pilots. Dun, 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 dun. All right, here we go. 21 Navy pilots. All right, now you ladies have to be careful, all right, because you need to make sure that we're dealing with the right gender, right? So notice when we do 21 through 24, notice at the very top, at the very top of the problem 21, it says men's heights are normally distributed with 68.6 and a standard deviation of 2.8, right? And the women's heights are normally distributed with a mean of 63.7 and a standard deviation of 2.9. So they're giving you the men's and the women's numbers, all right? So you have to be careful. You have to read the question and you use the correct gender readings. All right, so here we go. Let's do 21. All right, so it says the U.S. Navy requires that fighter pilots have heights between 62 inches and 78 inches. Find the percentage of women meeting the height requirements. Are many women not qualified because they are too short or too tall? Okay, so this one we're gonna have to do this one with the probability. Because they're not giving us percentage, right? That's what we're trying to find. We're trying to find a percentage. All right, so let's write down the all right, so my question is which numbers are we dealing with? Are we dealing with the females or the males for 21A? Males or females? Yes, we need the females. All right, so let me write down the mean and the standard deviation for the females. We want the women. The women. All right, so the mean for the woman is 63.7. Yeah, you don't want to use the males because then that would be Bruce Jenner, but that's another story. All right. The standard deviation is 2.9. What is it? Inches? All right, inches. All right. All right, so mu 63.7. Standard deviation for the women is 2.9. All right. Letter A. Find the percentage of women meeting the height requirement. All right, so what is their height requirement? Oh, it has to be between 62 inches and 78 inches. So we're going to have to write our probability. This is the in-between one. So we're going to put P parentheses 62 less than X less than 78. Oh, shoot, I'm not going to have space. Hold on. I wrote the freaking problem all large. 62 and 78. All right, so this is the in between. Oh, we want to find out if there's any is there gender discrimination going on and within the forces? Yeah, there's so much stuff going on in the military. Like that girl, I forgot her name, right? That little girl, that girl that was found in was it Fort? It's terrible, terrible. Yeah, Fort Hood. Yeah, there's so much stuff, man. They covered up. They just covered up. That's so stupid. Vanessa, yeah. Vanessa. Okay. All right. So here is. In between. All right. So we're gonna convert. We have to convert. We're gonna have to convert both numbers. All right. So here we go. Z equals X minus mu over sigma. I got to do it twice. I don't know why I put, anyways, x minus mu over sigma. All right, here we go. I'm gonna plug them in. I'm gonna put the 62 first. 62 minus 63 points. Yeah, I almost caught myself. I was gonna put 100. But that's the wrong question, sir. Right. And then we'll do the other number. 78 minus 63.7 and then divided by 2.9. I hope I have enough space. I don't think I am. Okay. And I'm gonna figure them out. Make sure that you have two numbers behind the decimal. Two numbers behind the decimal. Okay, so I end up getting negative 0.59. Yeah, that there is a 6 after the 8, so that's going to change that 8 to a 9, right? Because I want to have two numbers behind the decimal, so that 6 changes that 8 to a 9. That's why I have 0.59. And then the other one, I get 4.93. Yeah, this one came out 4.93. Yeah, I need two digits behind, so that 1 doesn't affect the 3, so that's 4.93. Okay, so now I can write my probability. I'm gonna write these two numbers now, negative 0.59, less than z, less than 4.93. And I gotta do in between. I'm gonna do Beyonce song, to the left, to the left. I don't know, I always put a little music note, so that way I know, hey, that's Beyonce song. Of course, y'all don't listen to Beyonce, do y'all? Y'all listen to what Ana Gabriel, who's another Ana Gabriel, Gloria Estefan. I don't know that many Hispanic singers now. Who's out there besides Ana Gabriel? Taylor Swift? I don't know. Hannah Montana. My mom calls her Hannah Montana. Hannah Montana. Miley Cyrus. El Miley Cyrus. My mom. Hi, my mom. Hi. Miley Cyrus. Is Gwen Stefani considered Hispanic? Never mind. No. All right. Left area of 4.93. Left area of negative 0.59. Cool. All right, so I'm gonna put these numbers in, and I gotta find the lefts of these two numbers, and then subtract them. Subtract, yeah. Let's see. Gotta plug them in. All right, here we go. I gotta. You gotta be careful. You gotta keep track of your little windows there. All right, so 4.93. Ooh, 4.93 is a 1. What the frog? Look at that. Left is 1. 1.00001. 0, 0, 0, 0. Oh, there's no 1. 0, there's 5 zeros? Is that right? Well, only 1, 4. 1, 2, 3, 4. All right. Minus negative 0.59. Nicki Minaj. There you go. That's another Hispanic singer, Nicki Minaj. Negative 0.59. 0.59. Left. To the left, to the left. 2776. All right. 2776. I'm going to swish. Swish. La Lady Gaga. 1, 2, 3, 4. Minus 0.2776. All right. My answer is 0.7224. 72.24%. All right. So what do y'all ladies think? Is there a so 72.24% of the women who apply for Navy pilot is qualified to fly. Are y'all comfortable with 72.24% of the females? Or you think that should be higher? What do y'all think? Are you happy with that? So out of all the females, 72.24 are able to fly because of their height requirement. I'm trying to find it. That's weird. That's 7211. 7220. You think it should be higher? Whoa, 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 whoa. That's right. I agree. I think it's yeah, I think so too. I think it's low. All right. So that's what J-Lo. Oh, that's right about J-Lo. I forgot about J-Lo. Oops, sorry, J-Lo. But she doesn't sing Spanish, does she? I don't know about J-Lo. I think she's, I don't know. How's my mom call her? A Wheela? What the heck is that? I don't know. I don't understand what my mom was saying. Wheela. But anyways. Okay. Let's do all right. So that's what part B is. That's what part E is. Part B. Not part E. Part B. So you guys are not convinced that that's a high enough percentage. So this is where the engineers come to play. Like, all right, so you don't like that percentage? Let's fix it. So here's what they said. All right, so they said if the Navy changes the height requirements so that all women are eligible except the shortest 3% and the tallest 3%, what are the new height requirements for the women? All right, so we're going to do some adjustments. So this is where the other formula comes into play because you see, they're giving you the percentages. So we're going to do two pictures. We're going to have to redo the minimum and we're going to have to redo the maximum. All right, so we're going to have to draw two pictures. One for the shortest, right? So the shortest is going to be capped off on the left side. There's the 3% because that's the shortest. And then we have to draw another picture for the tallest. I have this older student in my other class. I was drawing the picture. I'm gonna show you the picture that I drew, right? And gosh, I think she's like 60 something, or I don't know. Anyways, she talks a lot. She talks a lot. Anyways, and then I'm gonna show you the picture in a minute. All right, so we're gonna get the tallest. The tallest is gonna be capped off on the other side, 3%. Tallest. All right, so I drew this picture. I was all quiet. I didn't say anything. Everyone was just laughing. I was just like, I better not laugh because I muted everything and then I started laughing. Okay, so I drew this picture, right? And I said, well, what can you conclude from this picture that I just drew here? And then she goes, I think she's gonna need a plastic surgeon. What? A plastic surgeon? I don't get it. And then I was like, oh gosh, I should have put the graph. Well, you know. I can muchacha. Of course, everyone laughed. I did not. I was all incognito. I don't know. All right. Anyways, cochina murosa. All right. So let's do the shortest. So because this one is shaded on the left, we're all right. So we can go ahead and divide 3 by 100. So this would be 0.03, and I'm going to enter that number to find my Z. All right, so I'm gonna put 0.03 into StatDisk. So that's the shortest. 0.03. 0.0. Oh, that's why. 0.03. What? Okay, anyways, that was weird. And I want to get the Z. All right, here it is. Negative 1.88079. 0.0079. Negative 1.00. Negative 1.88079. And without me doing it in StatDisk, if this is negative, look at the numbers. This is the shortest 3. This is the tallest 3. What can you conclude about your Z number? They're the same, but different ends, which means that this number is negative, which means this one is correct, positive. Right, because they're symmetrical. If this is 3, that's 3. The numbers got to be the same, but opposite signs. So there's your tallest. And you're going to do that formula for the shortest, and you're going to do it for the tallest. So we're going to do that formula, x equals mu plus z times sigma, and then we got to do one for the tallest. And so we're going to plug in the numbers. I forgot what the numbers were. Shoot, what were the numbers? Nope. Did I do it? Oh yeah, here it is. No. I forgot what the numbers were. Oh yeah. The females were 63.7. The mean, and then the standard deviation was, forgot to write that down. You didn't tell me. You forgot to tell me. I forgot to write it down. No, hombre. Okay, here we go. Now I got the numbers. Now I can plug them in. Here we go. 63.7. And we'll do the shortest one first. Negative 1.88079. And then we multiply it times 2.9. And then this one we'll do 63.7 plus positive 1.88079 times 2.9. All right. And enter into your calculator. Calculator. Oh, 2.9. 58. There we go. 58.245709 inches. And then the other one is going to be the other one is 69.154291 inches. All right, so there are your two height requirements. All right, ladies, are y'all tall enough to be a pilot now? Now you can be a pilot. Do it. I'm gonna give Tomas Cruz competition. I haven't seen the Top Gun 2 movie. Have y'all seen it, or it hasn't come out yet? It looks stupid. Tomas Cruz. Right, and so there's your minimum and there's your maximum. Did you know that if you're a pilot, they have to customize your seat for your plane? Like, that's your plane. That's your plane. Isn't that cool? It's like your plane. You don't share it. That's just your plane. It's amazing. I don't know about flying. I think I like just being on the ground. Excellent. So do you see how the procedure is working? So you're gonna do you'll do a probability, and then you'll do one of these things. It's the same thing. You're gonna do the same thing over and over. All the problems are gonna be like that. They're all going to be like that. Very similar. Similar. What did I do with it? So you do that. You do that first. Probability, and then you do a find the x. And nothing's gonna change, ladies. Nothing's gonna change. You're gonna continue doing that in section 2.6.2. And we don't do 6.3, we go directly to 6.4. Now 6.4 is a little bit, it's slightly different. Just a small small little thing, but you're gonna do the same process, same thing. It's the same process, but we do something a little bit different. So let me show you. I'm gonna show you all on 6.4 how it differs from this. So we're not leaving this. We're gonna continue doing this all the time. So don't do the homework from 6.3. I don't think I assigned it, but it's not on there. But you'll see first, ladies, that in 6.4 we do the same thing, but it's called the central limit theorem. I hope I spelled theorem right. Central limit theorem. that's what the title of this section is called. It's called the central limit theorem. Now, I can explain it to you two ways. Do you want me to explain it to you as a mathematician, or do you want me to explain to you how it is in political science version? Anyone going to be a math major? Anyone? Anyone going to be a math major? No one's a math major. So you guys want me to explain to you as a fifth grader? The easy way. No, I think I'm going to show it to you in math terms. All right. All right. So let me show you the easy way. All right. So if I asked you all, where do you, all right, so where would you go and buy a good cup of coffee? Where do you usually buy your coffee at? Where do you buy a good cup of coffee? Anyone? Where do you buy, where's a good place you recommend? I mean, it doesn't matter, Starbucks, Dunkin' Donuts, whatever. Where do you usually buy your cup of coffee? A good cup of coffee? No, I don't think Michoacana Meat Market is a good place to buy it. Nice try. Taqueria Jalisco? What? Taqueria Jalisco? Which one? It's like a million of them. What? No one likes Starbucks?
I wouldn't say it's good, but I go to Dunkin'.
Dunkin'? Brevity? Where's that at? Brevity Coffee. Brevity Coffee. Brevity Coffee? Is that a place or that's a type of coffee? Should I write it down? Brevity. Okay, I want to write it down and to get there. It's a place. Where is it at? Is it in the south side? It's a place. Ah.
It's legit a small little building.
Is
like,
it?
in the corner of a lot.
Where is it at? Like, is it like
On
Stone
Babcock?
Oak? Oh, that's too far. That's like close to the Dominion, isn't it?
That way?
It's close to the Dominion, like going out that way.
Yeah, I guess. It's by the medical area, you know. Well, there's one over
Yeah.
here. I don't know if you're talking about that one, but that's the one over here.
Okay, all right. That's too far. I'm afraid I might get carjacked. Is it safe? I don't know. Brevity. All right, I'm gonna have to try it out. All right, all right, everyone is gonna have to go try it. Let's go. Let's all go. We'll meet there. All right. So all right. So brevity. All right. So brevity. All right. So brevity. I'm gonna use brevity as an example. All right. So yeah. So you said it's just one shop. All right. So let's say that you are the CEO of Brevity Coffee. They have frozen coffee. Well, how do you drink it if it's frozen? There's two of them. There's two. All right. Well, again, there's not one in the south side, right? Of course, yeah. I bet there's one in Stone Oak. I bet you anything. Damn it! Why do y'all have all that luck? All right. So let's say that you're the CEO of Brevity Coffee, right? And you want to expand, right? You want to expand more. You want to go ahead and put one in the east side and south side of good old SA. Yeah, I can't just leave it in the north side. Come on. All right. So you want to, you're thinking, I want to see if I can lure more people into drinking, go to my coffee shop. So I'm going to bring in this exotic coffee. Have y'all heard of this exotic coffee before? It's in usually it's like South America or India, where the coffee beans they're consumed by an animal. I don't know if it's a monkey or some animal that consumes the coffee bean. They're enzymes from their stomach does something to the coffee bean, and then it poops it out, and then someone cleans it, dries it, and then grinds it, and then coffee. There's your coffee. Have y'all heard of that one? You ever heard of that coffee? It's like exotic, and it costs $50 a cup. $50 or more. Look it up. I don't know what it is. I don't know what kind of animal it is. A cat or something? I don't know. So let's say that Brevity is going to, they're gonna go ahead and experiment with it, and they're gonna have the customers try it out, right? And so they're gonna call the coffee, they're gonna call it Cacachino or Crappuccino. That's a good name, right? Don't you think? Cacachino? Delicious. Chocolatey, nougaty. Cacachino. Would you try it? Would anyone try the exotic coffee? Cacachino or Crappuccino? Anyone? Some good crap. I'm serious. You gotta look it up. Look it up. It's some sort of animal. I don't know. We saw it in Peru when we went. They were selling it, and they were like, "Should we try it?" Yeah, go ahead, try it. The animal just eats fruit. I'm like, yeah, but it pooped it out. But it's good. And like, no, I'm going to pass. Yeah, well, that's what the monkey did. It passed.
I'm so
Okay.
gullible. I legit thought you were going somewhere with that.
It's true. Look it up. Cacachino. Look it up.
I thought you were talking about those jelly beans that like jump around, those Mexican like beans that jump. I was like, oh, I know.
No, that's a different. Yeah, I don't think you can make coffee out of that one. But that would be. I think that one would make you go squirts. I think you'll get the squirts if you eat that one. I don't know. But no, it's an exotic coffee. I'm telling you, go look it up. Look it up. It's some animal. I don't know what it is. It's like a cat or something. I don't know. But I'm like, what doofus was looking at the animal and saying to themselves, I wonder what the coffee would taste like if I were to eat it or clean it and try it out. I mean, what were they thinking? I guess they didn't have anything else better to do. Just sit around looking at that animal eat coffee beans, and then hey, it pooped it out, huh? I wonder what the coffee would taste like in that situation. Huh. Anyways, they're probably on drugs. I don't know. All right, so you're gonna experiment, right? So as a marketer, of course you're gonna have to test the product, right? You got to see if it's a go or not. You got to make sure that people like Cacachino or Crappuccino, right? So what cities would you pick? You need to do tests on them. Which cities would you test the product in to see if you get people to like it? What cities would you choose? It's got to be highly populated cities. What would you choose?
New
Which
York.
cities? New York. All right, New York. What else? New York. Any other cities? We need big cities. Let me see. What did you say? Miami. Yes, Miami. Is that how you spell Miami? Miami. LA. I know. LA. Where else? Where else? Um Chicago. Yeah, Chicago. Okay, someone said Laredo. I don't know about that. Someone said Helotes. Really? Helotes? That's a. Do y'all have a building there? Do you have a tower? Probably not. Helotes, Laredo. Helotes. I don't think that's a city. Okay, I'll put Helotes. Nemo. Chicago. What about Las Vegas? Las Vegas, right? Las Vegas would be good. And where else? Another big city. Think. Atlanta, maybe? Or Dallas. I forgot about Dallas. Hello. Hello, Dallas. Atlanta. I forgot about Atlanta. Yeah. Atlanta. All right. So here are your big places that you're gonna test your product. So for each city that you're going to test, you have to find the mean and standard deviation for each of them. For each of those cities, you got to find the mean and standard deviation to see if that product is a go or not. I think it's India. You were asking. Look up India exotic coffee, or South America exotic coffee. You'll see. You're like, what the frog? No, not a frog, a cat. The jumping beans. I remember the jumping beans. All right. So that's your goal. You're gonna have to find the mean and standard deviation of whether or not that product is going to be good or not. So what this central limit theorem is telling you to do is you're going to get the average of all the means. Find the average of all the means. Right? And this is how they notate it. They put mu x bar. That's the symbol for the mean of all the averages, right? And you also have to find the average of all the standard deviations. And they notate it as a mu with an x bar, like that. Right. So the more cities that you have to sample, the more normal the curve will be. Right. If you do a small sample, it's not going to be a normal distribution. You have to tackle enough samples to make it a normal. That's what the standard central limit theorem is saying. If you have to take the mean of all the means of all the samples, and you should get a normal distribution. So there's requirements for you to use. There's some requirements that must be followed in order for you to use the central limit theorem. So the central limit theorem, here are the requirements. All right, the samples must be normally distributed. It's got to say that, normally distributed, okay? And then the second thing is the number of samples must be greater than or equal to 30. This is how they write it. That's what the N is, number of samples. Number of samples. So your N is going to represent number of samples. Right? And then your mu x bar is the mean, is equal to mu. And your sigma x bar is going to equal to sigma divided by the square root of n. Okay, so whatever the mean you calculated, it's going to be the mu x bar. So what it's saying is that the actual mean of all the means is going to be one of these. We don't know which one it is, but we'll find out which one it is. But to calculate the mean of all of the standard deviations, you're going to calculate it by getting your standard deviation, and you're going to divide it by the square root of your number of samples. So who's up for getting a cappuccino? Anyone? Anyone up for a cappuccino? Did y'all look it up? Did anyone look it up? The cappuccino. Someone, you should have looked it up. It should be their exotic coffee. And it has a picture of the monito, right? The little animal. It looks cute. You would think that that animal doesn't poop, but it does. All animals poop. All animals poop. So that's what we're going to be doing. All right. So we're going to do this procedure. Now, how are we going to distinguish between the central limit theorem, and how are you going to distinguish that from a regular standard normal? All right. So on your notes, I provided on I think it's the 4th page. Yeah, on the 4th page of that handout that I gave you all, it has the notes. Let me share it with you. I can open it up. Page 4. Boom, right there. There is the note. All right. So you have 2 sides. Okay, you have 2 sides in this handout. On the left side is if you sample one item only, you're going to do what we did before in 6.2. You're going to find the mean, you're going to find the standard deviation, you're going to write down your probability statement, you're going to convert, and you're going to find the area. That's what this part is. That's what we did in 6.2. 6.4, you need to see how many samples are being conducted. If sampling more than one item, here's what you do. You're going to find the mu x bar, which is going to be whatever the mu is. They're going to give you a mu. You use that. You use the same mu as a one sample. Right? So this is going to be the same as that. The only difference is that when you do more than one sample, you're going to calculate this. You're going to have to do it by with your calculator. But it says here, do not round. You got to leave all your digits when you compute that formula. You're going to leave it all there. Just don't change it. You're going to write your probability statement. And when you write your probability statement, you're going to write it like this. You're going to write P parentheses X bar. It's like an ñ. Sorry. It's like a freaking ñ. I'm trying to write X bar. Close enough. And then you put your inequality. Right? And then you do your conversion and you find the area. Just like we did here, but it's just a little notation that's going to be different. Same procedure. Almost the same procedure. I really need to practice my drawing. That is just wow. What's the word that y'all use? Wonky? Is that the word? Wonky? I don't know your terminology, your generation. What the heck is a freaking wonky? Wonky. What is wonky, people? What is wonky? I don't know what the wonky. I thought it was Chewbacca's son, Wonky. I don't know what wonky is. All right. So there are your formulas. All right. So when we do 6-4, here's what's gonna happen. You're gonna do one of these on your left, and then you do one of these on the right. One of these on the left, one of these on the right. Part A, part B, part A, part B. And then when you deal with the word problems, they're all going to be part B. So we'll do several. How's that? Did y'all like that? Excellent. All right, so y'all have that handout ready? I'm gonna erase it. I'm gonna leave it there for now. But you guys have a copy of it, right? Should I send it chat again, chat wise? Let me see. Hold on. Let me forward it to you again on the chat. Here you go. Boom. There's chapter 6. Okay. Ready. Because if you get it wrong, you're gonna have to drink a sip of that cappuccino without any creamer. I see plain Jane. Oof. Gosh, you're thinking about it makes me. Oof. Ugh. Did anyone look it up yet? No one looked it up yet. Cacachino. ¿Qué cochino con cacachino? All right, let's see. She looked it up. I could not find it. What? No. It's supposed to be there. They probably took it down because people were they're scooping up all the stock in it. I don't know. It's supposed to be there. All right. So let's do a couple of examples from the homework. All right. All right. So you're gonna go to page. What page is it on? Page 272. I'm gonna show y'all. Page 272. Boy, you're gonna really understand the formulas really well with these exercises. Okay. All right, I'm gonna try to do one of each, and then hopefully we'll have time to do 2 examples from the homework word problems. All right, let's start with number 5, page 272. Number 5. All right, number 5, page 272, number 5. All right, so who can tell me what is the mean and standard deviation for this problem? For number 5. Correct. Y'all said it was 74. The mean is 74. Okay, mean is 74. Mu is 74 beats per minute. And your standard deviation was, that's correct, 12.5. Yeah, see it? Right there, there's the 12.5. So they'll give you the mean and standard deviation, folks. Right there, it's right here. Beats per minute. We got the beat. Is it we got the beat or we got big feet? I forgot how the lyric went. All right, number 5A. All right, here we go. Part A. All right, it says if one. Huh? What did I do? Okay. So if one adult female is randomly selected, find the probability that her pulse rate is less than 80 beats per minute. Okay, now how many samples are conducted for part A? Who can tell me? How many? Menudo. How many? Menudo. How many? It's 1, right? 1. If one adult, so you're doing 1. So you're going to use the left side. Okay, we're going to do the left side because it says we're doing 1 sample. All right, so I already know my mean. is 74.0. My standard deviation is 12.5. All I have to do is figure out the probability statement, right? So let's go back and look at the problem, and we need to figure out the probability statement. So it's going to be the probability of what? Probability that her pulse rate, so we're going to use X, is less than, oh, it tells you right there, less than 80. We're doing one sample. Less than, y'all see it? Less than. I won't let me highlight it. But it's right there, less than. Y'all can barely see it. Okay, so we got less than. And we're going to do the same procedure that we did before. We're going to convert. Use your formula. Z equals X minus mu over sigma. I'm going to substitute the numbers in. So you do the same thing like we did before, ladies. It's the same old. 80 minus 74 divided by 12.5. Put in your calculator. Calculator. That's what they should have called the coffee calculator. No, cappuccino. 80.74, right? Divided by 12.5. All right, so I got 0.48. Right. Then we go and convert this to Z is less than 0.48. This is less than, so it's the left area. We plug in 0.48 into StatDisk. Evaluate. I need the left area. 6844 is my answer. 0.6844 or 68.44% is my answer. Let me double check. Yep, bam. We're so good. 6844. We are so good. There is part A. Same thing like we did in 6.2. Same thing, right? Why? Because this is one sample. We're only conducting one sample. That's what 6.2 was talking about. We're conducting only one sample. Okay. Now, if we do part B, let's check out part B. Part B. Number B. What is number B? All right, number B says, if 16 adult females are randomly selected, find the probability that they have pulse rates with a mean less than 80 beats per minute. Sorry, with the sound effects. But yeah, that was a pretty good thumping of the heart. All right, so notice this one has 16 adults. So this one is a multiple sample, right? So that means our mean is still 100. I'm sorry, our mean is still 74. Sorry. Our standard deviation is 12.5. But my n, that's my n. My n is going to represent the 16 because it's 16 samples. So this is where you all are going to apply the central limit theorem because it's more than one sample. All right, so let me show you how it works. So I have n is 16 samples. So I have to go ahead then and find my mu x bar, it's subscript, mu x bar, and I gotta find my sigma x bar, right? So my mu x bar, my mean of all the means, is going to equal to my mu, which is 74. That doesn't change. It's the same. Look, it's the same as part A. Same thing. Same thing. Whatever your mu is, that's what mu x bar is. So that didn't change. However, your sigma x bar is going to be modified a little bit. So here's the formula for it. It's sigma divided by square root of n. So I'm going to plug in my mu, 12.5. And then I'm going to calculate the square root of 16. Right. And I guess I can do this by hand, but y'all see where your square root button is, right? Square root key is, where is the square root button? Square root button is second. I think it's right there next to the 7. There you go. Square root is 4. So you're going to do 12.5 divided by 4. And if I calculate 12.5 divided by 4, 3.125. Right. And I'm going to underline these numbers because we're going to use these numbers now. Right. Those are the numbers that we're going to use. I should box it. Let's box it. Right, I'm going to use those. All right. Now, how do I write my probability statement? So you do the same thing like we did before. You're going to write your P. But instead of writing an X, we're going to put X bar. I'm going to tell you why we use X bar. If you go back to the problem, it says if 16 adult females are randomly selected, find the probability that they have pulse rates with a mean. You see it? It says mean. That's why you have to put the X bar, because this is mean is less than 80 beats per minute. See it? Mean is less than 80 beats per minute. So that's why we have to put X bar. X bar is less than 80 because this is mean. And you know what I mean? That's mean. That is so
What does the X bar even mean though?
X bar, what does it mean?
Yeah,
It's the mean of the samples.
that's literally all it means.
That's what it means, yeah. You're so mean. Yes, that's what it means. It's the so you have these 16 items. You're sampling one from each sample. That's what you're doing. Well, you're finding them. Yeah, you're finding the samples. Those 16 are your samples. That's what it is. And so it's basically it's just a symbol. That's all it is. Basically what it is. And then we're going to convert like we did before. Right, we're going to convert like we did. I'm gonna stick with the formula so that way you guys won't get confused. But it's the same. It's almost the same formula, right? So it's really x bar minus mu x bar divided by sigma x bar. It's pretty much the same formula as we did before, right? So your x bar is this 80, right? And we're going to subtract my 74, and we're going to divide by 3.125. So if you prefer to write it as x minus mu over sigma, you can do that. It's just pretty much the same number. Look, 80, but don't get confused. You're not going to use these anymore. You're going to use the ones in the box. 74, and then the 3.125. It's pretty much the same formula. All right. And then we calculate it. I'm going to divide. I'm going to subtract and then divide. So 80 minus 74.0 divided by 3.125. I get 1.92. $1.92. Now, if you look at this formula from part B and compare it to the formula from part A, what is the only difference? Look at this line right here, this one and this one. What's the difference between that formula and that formula? The only difference is what? You all see that the top is exactly the same. It's just the bottom. You see the bottom was the standard deviation. And the one for the multiple samples, you get your standard deviation and you divide by the square root of n. That's pretty much the difference between the two formulas, is just the bottom part. And then you do the same procedure. You do z is less than 1.92. And we are going to look at the left area. We're going to enter 1.92 in StatDisk and find the area of 1.92, and then that'll be my answer. You guys can double check to see if we are accurate. Accurate. Plug it in, 1.92. There it is, 9726. 0.9726 or 97.26%. So it's pretty much the same idea. It's just your denominator on your conversion is going to be changed. You got to divide your sigma, that 12.5, by the square root of your number of samples. Whereas the previous one, you're only dividing it by the standard deviation. It's the same, 12.5. This one you have to modify it. You have to divide by the square root of the number of samples. That's pretty much it. You're doing the same things as you did in 6.2, just a little modification, a little modification. All right, so we did a less than. Should I do one of each? Should I do a greater than and an in between so y'all can see how it works? Does that sound like a plan, Stans? All right, so we did an example of when your inequality are less than's. Okay. Let's do one that has greater than. I think I ran out of paper. Yeah, I think I ran out of paper. Yeah, I ran out of paper. Okay, hold on. I ran out of paper. I ran out of paper. Where did the paper go? Paper, paper. Paper, paper. Paper, paper. Paper, paper. Paper, paper. Okay. I got it from the back of the truck, so just letting you know. All right. Let's see. Compadritas. All right, let's see. Let's continue. Let us do, I need to do one that has a greater than. Who can find me one that has greater than? Oh, we didn't do part C. All right, sorry, I forgot to do part C. Yeah, thank you. Someone said, why can the normal distribution be used in part B, even though the sample size does not exceed 30? Well, there were two requirements, weren't there? What were the two requirements, people? You remember what the requirements were? There were two requirements. Where is the requirement? What was one of the requirements? You don't remember? I can't find it. I was on the Kakachino. I don't remember what I put the requirements. I know one of them said that it had to be greater than 30, right? There was another thing it said. Didn't it have to say that the problem has to state that it was normally distributed? Does it say it there at the very top of the instructions? Does it say anywhere on there that it's normally distributed? Y'all see it? It should say it there. Who can find it? Who can find that? It has to say. It has to say. It has to say. Samples must be normally distributed. You guys see it? Right there. Boom. It says it there. So we can apply the central limit theorem because it says normally distributed. That's fine. So that's what you would put for part C, because it states it's normally distributed. There's your part C. All of them are going to be like that, people. You just state that there. Anyways, there you go. There's your part C. All right, we need to do one that has a greater than. Who can find me one that has greater than? Oh, thank you. Number 6. Excellent. All right, let's do 6. All right, so 6. Let's write down our mean. What was our mean, Jelly Bean? Our mean for number 6 is, what was it? I went too high up. 74.0. And our standard deviation is 12.5. All right, we got that. What is part A asking? How many samples are we conducting for letter A for number 6? Is it one or multiple samples? One. We'll give it away. There's a 1. One sample. All right. Since it's one sample, I'm going to write down my probability. So my probability is P parenthesis X is greater than, there it is, greater than 70. Okay, this says it there, greater than 70. Okay, and so we do our titty. X is greater than 70. I'm going to convert. E equals X minus mu over sigma. You see, I'm doing the same thing over and over again. It's nothing strange. 70 minus 74 divided by 12.5. Plug it in. 70 minus 74. And it's okay, people, if you get a negative, that's fine. That's perfectly fine. You can get negatives. Don't panic. Like, oh no, I got a negative. That's okay. You can get negatives in your conversion. You just can't get a negative on your answer, your area. You can't. All right. So we get that. I'm going to write my probability. Now it becomes a z. It's greater than negative 0.32. Since it's greater than, I'm looking at the right area. So I'm going to plug that number in to stat disk. That's a parenthesis, not a 1, people. Sorry. My parenthesis looks like a 1. Put that into stat disk. Ratata, ratata. I think I do need cappuccino. It is 0.32. Right. 255. 0.6255 or 62.55%. Y'all can check the answer at the back of the book. I'm going to double check for part A. Booyah. Oh, you don't have the answers for evens. Aha, but I do. 62.55. We're good, baby. We're good. Yeah. Love me my Austin Powers. Cha-ching. Cha-ching. Ladies, all right? I can hear your brains frying. That's a good sign. That is a very good sign. I can hear it sizzle. Like carnitas. Yes. So on this part, we do not round. What was it? Hold on. What was the number? Yes, we do round this one. This one we have to round to 4 places because the two is the 5th spot. So we would mark that off. So yeah, it would just be 62.55. So your answer for your total answer for the entire problem is 4 places, but your conversion is 2. 2, 4. Good question, ma'am. Good question. Conversions 2, answer is 4. 2 and 4. Okay. That answer, is that good? So far so good? All right, part B. If 25 adult females around me selected, find the probability that they have a pulse rates with a mean greater than 70. All right, I'm gonna write down my mean again. Mu is 74.0. Standard deviation is 12.5. Notice on B, I am sampling 25 samples. This is my N because there's 25 samples. That tells me that I'm going to use the multiple sample formula. So I'm going to use this side. So I have to write down, I got to figure out what these values are, and then I have to write down my probability statement with the X bar. So let's go back and find the probability statement. What is your probability statement? Probability statement is find the probability that they have pulse rates with a mean greater than 70. So that's why you put X bar is greater than 70. That's why you write it like that, because that's what it says. It says mean is greater than 70. Oh, goodness. 70. And so you're going to go on the side and you're going to compute these two formulas, right? So your mean X bar is simply the 74. You just copy it straight off. It's the same. This one you will have to compute. You're going to have to do sigma divided by the square root of n. So you do 12.5. That's what this number is. And then you divide it by the square root of 25. I know that square root of 25 is 5, right? So I can divide 12.5 divided by 5 is 6.25. Did I do it right? No, I didn't do it right. 12.5 divided by 5 is 2.5. I knew it. It was 2.5. I ran out of space. And I'm going to convert. By now, I think you got the formulas pretty much memorized. So it's 70, right? 70 minus my mu, 74.0, and I'm going to divide it by 2.5. 2.5. Negative 1.6. Is that correct, ladies? I got negative 1.6. You're going to look up the right area. Why do we look up the right area? Because of this. It's greater than. Greater than means you have to look up the right area. And so we look up negative 1.6 on stat disk, right? Right. That's what yeah. See what brainwashing, how it works? Isn't that cool? Cacachino. See if that works. All right, let's go plug in 1.6, 1.6, negative 1.6, negative 1.6. I forgot the O. Whoops. I knew if I got the 0. Hello. Doesn't matter if you put the 0. Anyways, I'm gonna put it on there. Right is 94.52. 94.52%. 94.52% is my result. Sakamoto. I'm gonna check. Booyah. We're so good. We are so good. So there is your example of one that involves greater than. So we did a less than. We did a less than that had to do with 6.2, and now we had a, this is 6.4. This is the 6.2 portion. This is the 6.4 portion. Y'all seeing the pattern with it? Do you see how we keep continue to use the same formulas over and over and over and over again? That's how it works. All right, we got a greater than. Now we have to do an in between. All right, I'm gonna let you laddies, tell me which I need to do one that has a in between. Which one should we do that has an in between? You want to do there's a whole bunch of them. Do you want to do 7, 8, 7 or 8? Which one would you like? 7 or 8? 7. Lucky 7. Excellent. All right, let's do 7. All right, 7 it is. 7. 7 it is. All right, here we go. 7. Again, what is your mean? What's your standard deviation? My mean is still the same. I got to go back up here. There's my mean, 74. Standard deviation is 12.5. Okay. And for part A, it says, what does it say? If one adult female is randomly selected, find the probability that her pulse rate is between 72 beats per minute and 76. All right, there's your probability statement. It's in between, so I got to put the 72, P parentheses 72 less than X less than 76. Yeah. It's a one sample. One sample. We're doing one sample. That's what it says. It says one sample. And we convert. Convert. Oh, I gotta do 2 of them. Son of a biscuit. I gotta do 1 per number. Nombre. All right, here I go. 72 minus 74 divided by 12.5. And then the other one is 76 minus 74, 12.5. I go, it's I'm gonna go quick. All right, so here's 72. That's for the 72, that's for the 76. All right, we're gonna calculate it. Negative 0.16 is the first one. I think the other one's positive 0.16, I think. Huh, it is. I am psychic. It's the same number, but opposite signs. What a coinky dink. What a coinky dink. Negative 0.16 less than Z less than 0.16. Oh, this is the one that I gotta do Beyonce's. To the left, to the left. To the left. Left area of positive 16 minus left area of negative 0.16. So I gotta plug in on stat base. I gotta do each one individually. I gotta plug them in and get me my areas and then subtract the two areas. All right. 56, 36. 56, 36. 0.5636 minus, now I'm gonna put them negative. 4364. 0.4364. 43. Bless you. Someone sneezed. Bless you. Mocosos. And subtract. $12.72. $12.72. Bingo. 0.1272, 12.72%. I'm gonna double check. Yes. And we're on a streak. We are on a streak. We are on a streak. It's good to be right all the time, you know? Yeah. All right. Number B. It's a pain in the buttocks writing these numbers, right? Have you seen my hand? Look at my hand, ladies. Look at my hand. I need to take a bath. I need to take a bath. All right. Letter B. How many samples are we conducting on letter B? Letter B. Letter B. How many samples are we conducting on letter B? We're doing 7. Oh, we're doing 4 samples. Well, all right, so that's 4 samples. All right, that tells me right there that I have to do those 2 formulas. And I gotta find the probability of what? 7. Find the probability that they have pulse rates with a mean between 72 and 76 beats per minute. All right, so I'm gonna put probability, I'm gonna put P parentheses 72 less than X bar and less than 76. You're conducting the means. So that's how you write it. That's how we write our probability. I have to go over here and I have to compute. I got to compute these numbers on the side. This is the same, 74. This one's going to change. So I'm going to do sigma divided by the square root of n. This is 12.5 divided by, what's the square root of 4? Square root of 4 is, anyone? Can y'all say it? It's, how do y'all say it in Helotus? Tau. It's tau. Is that how y'all say it? Tau. We don't say two like that in Legacy, right? Desiree, we don't say tau like that. We say tu. Tu. No me, pero tu. Uh, 6.25. Great, I ran out of space. Son of a biscuit. Convert. We got to do our conversions twice. We got to do it for the 72 and we got to do it for the 76. Son of a biscuit. I'm running out of ink. All right, let's just plug it in. Why not? We don't have to put the formula, right? I'm tired of putting the formula. All right, so I'm gonna put 72. I'm gonna put 72 minus 74, right? 74 divided by, oh, sorry, 74. 74 divided by 6.25. And then the other one, I'm gonna do 76 minus 74.0 divided by 6.25. Sorry, I'm sniffing. We're making turkey legs in the oven. So 72 minus 74 divided by 6.25 is negative 0.32. I bet this one is positive. I bet that one's positive. Just saying. Just saying. Booyah. I was right. Ah, psychic. Beyonce, to the left, to the left. Area, left area of 0.32. Left area of negative 0.32. And I cut it close. I'm going to look up the both areas, both numbers, the positive and its negative counterpart, and subtract them. Subtract them. Yeah. Yeah, subtract them. Left. 6255. 0.6255 minus, now I got to do the negative. 3445. Ooh, that 4, the second 4 becomes a 5. You know? Yep, because the 8 is bigger than 5. So that's 3745. 45. And winner is subtract 0.6255 minus 0.3745, 0.2510. All right, let's check the answer in the back of the book. Oh, we're so good. Oh, why must I be so smart? You have to say that to yourself when you get the answer right, ladies. You have to say that to yourself all the time. Why do I have to be so smart? You got to build confidence. That's how you succeed in college and university. You keep reminding yourself you are so smart. Always. Whether things are get you down, you have a bad day, someone creates a bad day for you, you have to say to yourself, I am smart, I can do it. It doesn't matter the outside, it's what matters on the inside. Confidence. All right. Questions? All right, we got to do one more. I think we can do it in 10 minutes. All right, now I'm going to warn you all. I think there's a couple of them where you'll have to do the same procedure. You have to do part A, part B. But there are other ones where you're just going to do this part only, the 6-4, the multiple samples. So you have to read it. Read the problem carefully. You may not have to do both things. You may have to do one. And so what you have to do is you have to locate and determine how many samples are being conducted. They'll tell you, it'll state it on there, 15, 36, whatever. It'll say the number of samples. If it doesn't say number of samples, then it's just one sample. You're gonna do the 6-2 procedures, right? So just be aware of that. All right, here we go. I'm gonna let you all pick. Here are your choices. Are you interested in elevator safety? That sounds interesting. Are you interested in Mensa? Sorry. You are interested in 13 water taxi safety. That was, look, and the guy and the stupid author, he spelled it as it were the bad version, the Spanish version. It's supposed to be all capitalized. He's mental. He was supposed to put everything capital. Idiot. He's so mensa. Anyways, 13 water taxi safety. He doesn't know. He's not from the south side. Or you're interested in Southwest Airlines seats or redesign of ejection seats. Which one are you interested in? Is there another one? Pick one. Doorway heights. I forgot about that one too. Which one would you like? Doorway heights, redesign of ejection seats. That would be cool if you had that in your car, wouldn't it be? Southwest Airlines seats, water taxi safety, Mensa. Let me stop saying that. Or elevator. Pick one, ladies. Pick one. Which one would you like? They're all the same. They're all equally the same. They're all the same. They just ask for different questions. Which one would you like? All right, someone picked. Hey, don't be calling me names. I thought we were friends, Aniqueta. She's calling me Mensa. Que gacho. Man, that's messed up.
No, I'm not calling you.
Hijo. All right, I'm taking you off of MySpace. That's it. This is where we go. All right, fine. We'll do Mensa. All right, here we go. All right. Membership in Mensa requires a score in the top 2% of the standard intelligence test. All right, the Wechsler IQ test is designed for a mean of 100 and a standard deviation 15. And scores are normally distributed. All right, there you go. So, there you go. Number 11. Your mean right off the bat is 100. Standard deviation is 15. Okay, all right. Now let's look at part A. Now, part A, ooh, they threw a wrench at you. That was a good one. You picked a good one, Etiqueta. Find the minimum Wechsler IQ test score that satisfies the Mensa requirement. Okay, now, this one was interesting because at number 11, it gave you a percentage. Do you all see it? It says the requires a score in the top 2%. Top 2. So we're going to have to draw a picture of it because they're asking you for the minimum requirement. So we're going to draw a picture and we have to identify where the top 2% is. How do I draw it? Where do I draw the top 2%? Well, as you recall, the top is just top, right? Top is capped off at the very right end, and this is going to result in your 2%. But this is what we need. We need to find my Z, right? So I can't put 2% in StatDisk to find my Z. I need the left side. So if this is 2%, ladies, what's this side? Remember, both of them have to equal to 100%. So if this is 2%, that must mean that this is 98%. And that's the number that we're going to enter in StatDisk. So I got to change 98 to a decimal. So I think this is going to be 0.98. You're going to enter that and you're going to find the Z for it. Quickly, quickly, quickly. Let's find the Z. Shall we? Z. All right, take that off. 0.98. Let's find my Z. There it is. 2.05373. There's my Z. Let me see if you ladies remember what formula are we going to use to find the actual IQ score? Is it the conversion one or is it the other one? How did it go? I forgot how the formula went. It was X equals mu plus Z times sigma. Right. And we substitute 100 plus 2.05373, and we multiply it times 15, and this will give us our IQ. Let's see, what does my IQ score have to be in order for me to be accepted into Mensa? Sounds weird. It's only an elite group that are Mensals. 05. Whoa! You have to have a IQ of 130. Damn! No, I'm gonna forget it. I think I'm gonna stick with the other club, the regular people. Wow, that's a high IQ score. Damn. That would not be a politician. So there's your IQ score. You have to have a IQ score of 130, the top 2%. Damn, that's freaking high. I wonder if you can move objects with your head with that. I wonder if you can do chores around the house with an IQ like that. Maybe you can do it with your head. I don't know. So there's part A. All right, now part B. What is part B? What is part B? Where is part B? There it is. If 4 randomly selected adults take the regular IQ test, find the probability that their mean score is at least 131. Ooh. All right. So do you see how many samples are being conducted in letter B? There's 4. You see it? 4. Right. So let me write down my mean. My mean was 100. Standard deviation is 15, right? And number of samples is 4 samples. All right, now I need to write the probability. So this is going to be the tricky part. So we're trying to find the probability that the mean is at least 131. What the heck does at least 131 mean? Is it greater than or less than 131? Or less than or equal to, or greater than or equal to? At least. At least means that's the smallest that it can go. That's the smallest, at least. So I'm thinking it's going to be greater than. X bar is greater than 1. That's what at least. X or more, I think. At least. Greater than. Greater than. You got to think about it. You want at least 5 dogs. Wow, that's a lot of dogs. You want minimum is 5. That's the smallest that you can go. I don't advise that, but hey, if you like dogs, damn, 5 dogs. Oof. I only have 1. 1's enough, at least. So that's what that means. All right, so we're gonna find mu x bar and sigma x bar. So I'm going to use my 100. I don't need that anymore. My sigma x bar is going to be sigma over the square root of n. So that would be 15 divided by square root of 4. That's 15 divided by 2. What is 15 divided by 2? I think it's 7.5. Is that correct? Let me see. Is it? What is 15 divided by 2? Huh! I did it. Right. Ah, shoot. And we're going to convert. Am I going to have a space? Convert. I don't think I'm going to have space. Convert. Not convent. That's something else. All right. Z equals, all right, plug it in. Plug in the numbers. 131 minus 100, right, divided by 7.5. All right, so I got this long ass number, 4.13. I need 2 places. So that would be 4.13. The 3 is small, so it has to stay through. 4.13. Right, so we're gonna do probability of Z being greater than 4.13. And because it's greater than, I'm gonna look at the right area. Okay, it's greater than, right area. So I'm gonna go up to 4.13 in my stat disk. And let's see what we get. Aren't you curious? Ooh, what's the probability that these people have IQ scores that are above 131? Let's see, 4.13. Right area. Oh, look at that. 0.000. Ooh, that's 0. Wow. Or I mean, wow, that's, are you serious? What the frog? Yeah, it's what yeah. What the, I'm gonna put here, I don't think it's entirely 0. I'm gonna, that's small. Technically, it's, if you round it off, it is 0, right? But I don't want to put 0 because that means there is no chance of anyone getting an IQ above 1.13. I mean, technically, it's supposed to be 0.000, but in actuality, it's really 0 plus, right? Not that many people would qualify to be in the Mensa. It's a small bitty part of the population that can be in that group. Isn't that weird? Dang it, I can't get in. So there's a little kid that graduated from college, and he's only 7 years old. He graduated from college. He already has his bachelor's degree. Can you believe that? He's 7 freaking years old. Jeez. I wonder what they feed him. Do you think he eats cornflakes or Pop-Tarts or Captain Crunch, or what do they feed him? What do they feed him? I need to know the secret. What is the secret? I don't think he eats tacos. Let's like mark that off like quick. What does that kid eat? He probably just drinks milk straight from the cow, like from the udder. Just boom. That's why he's so smart. Instead of all those chemicals, those growth hormones. I don't know. We don't know. We're not gonna judge. But anyways, there you go. There's your. That's what I was talking about. You see how Part B incorporates what we've learned with the multiple samples. So all of them, pretty much all the rest are going to be multiple samples. So there is your 6-4. The end. Now y'all can go memes. Y'all can go memes. Yes? No. Any questions? Any concerns? Anything? Yeah? Oh, you're yawning? Is that a yawn or a yeah? Yeah. I think you're supposed to put tan. Tan. Yeah. Someone got mad. They all left. Done. There you go. Done. All right, you guys have a good weekend. I'm gonna be grading your stuff, so don't worry about me. You can have a alcoholic beverage this weekend. My treat. There you go. Have a good day. Bye. Bye.